On a chilly morning in 1942, at a sprawling Boeing factory in Wichita, Kansas, the air was thick with smoke, steam, and the nervous energy of thousands of workers laboring on what would become one of the most ambitious aircraft of World War II, the B-29 Superfortress. From the outset, this plane was cursed with a reputation that no designer or engineer could shake. Officially, it was meant to be a long-range, high-altitude bomber capable of striking deep into enemy territory with unprecedented payloads, but in practice, it was considered the worst bomber in American military history, at least during its early development. The skepticism began not on the battlefield, but in the design rooms and test hangars where every specification seemed impossibly ambitious. Pressurized cabins, remote-controlled gun turrets, and a range that could cover thousands of miles with heavy bomb loads. All of these features, revolutionary on paper, combined to create a machine that defied conventional aviation wisdom. Pilots and military leaders alike watched with a mix of awe and apprehension, their confidence tempered by the glaring evidence that this plane might never fly as intended. The B-29's engines, the mighty Wright R-3350 duplex cyclones, were designed to propel the massive airframe across oceans, carrying tons of bombs to targets the Axis had previously considered untouchable. But in reality, these engines were a nightmare. Overheating was constant, often resulting in catastrophic fires that could ignite mid-flight. Structural failures plagued early prototypes, wings flexed beyond safe limits, control surfaces faltered, and vibration caused entire panels to shear off in testing. Production delays mounted as each new prototype revealed flaws that required redesigns, sending engineers back to the drawing board again and again. Test pilots described flights that were terrifying. The plane shuddered violently on takeoff, climbed erratically, and exhibited strange aerodynamic quirks that seemed almost alive in their unpredictability. The more they flew it, the more it seemed like a ticking time bomb, a brilliant concept doomed by its own complexity. Military brass, who had authorized the plane with high hopes, began to doubt the wisdom of the decision. "This bomber will never leave the ground safely," some officers muttered. Pilots, trained on smaller, more reliable aircraft, looked upon the massive four-engine behemoth with equal parts fear and incredulity. The B-29 was so advanced that it outstripped the ability of everyone involved to fully understand it. Its pressurized cabin, intended to protect crews from high-altitude conditions, was a marvel, but in early flights, it malfunctioned frequently, leaving crews with nosebleeds, dizziness, and near-hypoxic conditions. The remote-controlled gun turrets, designed to allow gunners to operate multiple weapons from a protected station, jammed under combat conditions, creating frustration and life-threatening vulnerabilities. Each flaw, each failure, compounded the doubts surrounding the aircraft. Headlines in internal military reports described the plane as dangerously unreliable and a technical monstrosity. Yet despite all of these warnings, the B-29 represented an idea too important to abandon. The United States was locked in a brutal conflict across the Pacific, facing fortified Japanese islands and a sprawling enemy that could strike across vast distances. Conventional bombers, like the B-17 Flying Fortress and the B-24 Liberator, were inadequate for the distances needed to reach Japan's industrial heart. If the U.S. was to bring the war to the enemy homeland, it required a bomber that could fly farther, higher, and carry heavier payloads than anything in the existing arsenal. Desperation, coupled with faith in American engineering, meant that even the worst bomber had to be pursued. Engineers and assembly workers, many of them women and recent recruits with minimal experience, worked tirelessly under extreme pressure, often pulling 18-hour shifts to meet production schedules. The factory floor was a symphony of chaos, welders sparking, rivet guns pounding, and supervisors running from station to station, checking engines, wings, and hydraulics, all while the clock ticked ever closer to the day these planes would leave the factory and face real combat. The irony of the B-29 was that its very reputation as the worst bomber became a catalyst for innovation. Every problem discovered in flight tests forced engineers to invent solutions: engine cowlings to prevent fires, redesign propellers for stability, reinforced wings to handle heavy payloads, and more reliable hydraulics to stabilize the massive airframe. Skepticism from military leaders fueled a relentless cycle of testing, failure, and improvement. Pilots who initially feared for their lives began to notice subtle signs of progress. Minor tweaks in the engines and control systems improved stability and reliability. Slowly, what had once been viewed as a doomed experiment began to transform, a testament to human persistence, ingenuity, and the wartime imperative to solve problems under impossible pressure. In the end, the B-29's early reputation as a worst bomber was not a reflection of its potential, but of the enormous leap it represented in aviation technology. Every overheating engine, structural flaw, and production setback was a necessary step toward building the plane that would eventually carry the war into Japanese territory, change the dynamics of aerial combat, and become an instrument capable of ending a conflict that had stretched across the globe. The fear, skepticism, and doubt that surrounded the B-29 in its infancy make its eventual triumph all the more remarkable, reminding us that sometimes, the most dangerous and derided ideas are the ones that hold the power to redefine history. A desperate need. By 1943, the United States found itself grappling with one of the most formidable challenges of the Second World War, the vast expanse of the Pacific theater. Unlike Europe, where distances between enemy targets were manageable with existing bomber fleets, the islands of Japan were spread across thousands of miles of ocean, fortified, and well defended. American strategists recognized early on that conventional bombers, like the B-17 Flying Fortress and B-24 Liberator, simply lacked the range, payload capacity, and survivability to strike the Japanese mainland effectively. Every mission required a chain of forward bases, risky island hopping campaigns, and planes operating at the very limits of their fuel capacity. The Pacific was a theater defined by distance, isolation, and logistical nightmares, and the failure to reach Japan's industrial heartland threatened to prolong the war indefinitely. Each raid on island fortifications highlighted the inadequacy of the current bomber fleet. Planes often returned damaged, crews exhausted, and targets barely touched. Military leaders faced a stark reality. Unless the United States could field an aircraft capable of flying 3,000 miles or more while carrying a significant bomb load, Japan's war machine would continue unabated. Every day that conventional bombers failed to reach the homeland meant continued production of ships, aircraft, and weaponry that could strike back at American forces across the Pacific. Factories in Tokyo, Osaka, and Nagoya were churning out warplanes, munitions, and naval equipment at an alarming rate. The Allies needed a solution that could transcend the limitations of conventional aviation, an aircraft that could carry massive payloads, operate at altitudes high enough to avoid most anti-aircraft fire, and fly distances previously considered impossible for a bomber of such size. The war depended not just on tactical victories, but on strategic bombing that could cripple the enemy's capacity to wage war. The stakes were staggering. Japan's geography made every conventional bombing raid a perilous venture. American bombers needed mid-ocean refueling stops, which were nearly impossible, or to rely on captured or hastily constructed island airstrips that were within range of enemy counterattacks. Long-range reconnaissance and intelligence missions showed that Japanese defenses were heavily concentrated around strategic islands and the mainland, leaving little margin for error. The loss of even a handful of bombers on these missions had the potential to derail larger operational plans, costing both lives and morale. It became clear that an aircraft designed specifically to overcome these geographic and logistical challenges was not a luxury, it was a necessity. Without it, Japan's industrial base would remain untouchable, and the war could drag on for years, claiming tens of thousands more lives across both sides. Enter the B-29 Superfortress. Though plagued by technical problems in its early stages, this bomber represented the only viable solution to the United States' strategic dilemma. Its design incorporated pressurized cabins, allowing crews to survive at high altitudes over long distances. Its massive payload capacity meant that a single sortie could destroy critical industrial facilities that previously would have required multiple missions by smaller bombers. And its range, unprecedented at the time, made direct strikes on the Japanese mainland feasible, finally giving the Allies a tool that could hit the enemy where it hurt the most. But achieving this capability came with enormous risk. Early test flights were perilous, and skepticism among military leaders was rampant. Could a plane that struggled so dramatically in testing truly perform under combat conditions thousands of miles from home? Could it survive the tropical storms, mechanical failures, and enemy defenses that awaited it over the Pacific? Every aspect of the B-29's design had to be perfect, for there would be no second chances once it embarked on a mission deep into hostile territory. The urgency of the Pacific campaign accelerated production and innovation at an extraordinary pace. Factories operated around the clock, assembling these enormous aircraft with painstaking attention to detail. Engineers worked tirelessly to solve persistent problems like engine overheating, structural stress, and unreliable remote gun turrets, often using trial-and-error methods under tight deadlines. Test pilots risked their lives every day, flying prototypes that could literally fall apart mid-air. Each successful test flight, no matter how small, brought the Allies closer to the ability to reach Japan's industrial centers and shift the strategic balance. It was a race against time, technology, and the enemy, with the lives of thousands of soldiers and civilians hanging in the balance. In essence, the B-29 was more than a bomber, it was a lifeline. Its development underscored the desperation of the United States in the Pacific theater and highlighted the stark contrast between ambition and feasibility in wartime innovation. The conventional tools of the air war were inadequate, and only through sheer determination, ingenuity, and risk-taking could the U.S. hope to strike at Japan's heart. The plane that had been derided as the worst bomber suddenly became the most important, for the survival of both American forces and the ultimate success of the Allied strategy depended upon it. Every decision, every engine redesign, every sleepless night in the factory or test hangar contributed to a goal that seemed nearly impossible, ending the war in the Pacific by targeting the enemy where no conventional force could reach. The stakes could not have been higher, and the world waited for a machine that, until recently, was doubted at every turn. Engineering the impossible. The B-29 Superfortress was not merely a plane, it was the culmination of a Herculean engineering effort that pushed the boundaries of aviation in the 1940s. Designed and built by Boeing, with critical input from the U.S. Army Air Forces, the bomber's development became a test of human ingenuity, perseverance, and sheer willpower. From the outset, engineers faced challenges that had never been solved before. The B-29 was to operate at altitudes far higher than previous bombers, requiring pressurized cabins to keep crews alive during extended missions over enemy territory. This seemingly simple requirement presented unprecedented technical hurdles, sealing an aluminum fuselage against leaks, maintaining structural integrity under the stress of pressurization, and ensuring that all on-board systems, navigation, communications, armament, could function flawlessly in a near-vacuum environment. Every rivet, panel, and bulkhead had to be meticulously designed, for failure at 30,000 feet could mean instant disaster. The pressurized cabins alone required innovations in materials, manufacturing, and assembly techniques, representing a level of complexity rarely attempted in wartime aviation. Engineers also grappled with one of the most infamous issues in the B-29's development, the Wright R-3350 engines. Each of the four massive 18-cylinder radial engines produced enormous power but were prone to overheating and catastrophic failure. Fires during early test flights were common, and entire prototypes were grounded while teams attempted to resolve the persistent problem. The solution demanded meticulous attention to airflow, cooling, and metallurgy, combined with constant testing under extreme conditions. Mechanics and test pilots endured countless hours monitoring these temperamental engines, pushing them to their limits in a relentless search for reliability. The risk was staggering. Thousands of man-hours, millions of dollars, and the lives of test crews were at stake, yet the engineers refused to yield to the limitations of existing technology. Each success, no matter how small, was a triumph of human determination over mechanical unpredictability. Another revolutionary feature of the B-29 was its remote-controlled defensive armament system. Unlike any bomber before it, the Superfortress allowed gunners to operate multiple .50 caliber machine guns remotely from pressurized stations inside the fuselage. This innovation reduced weight, improved accuracy, and protected the crew from extreme altitudes, yet it introduced a new layer of complexity. Engineers had to design precise electrical systems, gyros, and sighting mechanisms that could reliably target enemy fighters across hundreds of feet of aircraft structure, while surviving the vibration and stresses of high-speed flight. Every system had to communicate flawlessly. A failure in targeting or operation could spell disaster during combat. Testing these systems required inventive solutions, from mock-up turrets to live-fire exercises, often pushing teams to the edge of their expertise. Beyond technical hurdles, the development of the B-29 highlighted the monumental human effort behind the machine. Thousands of engineers, designers, assembly workers, and test pilots poured their skill and energy into a project that many doubted could succeed. Factories ran around the clock, employing tens of thousands of workers who painstakingly assembled fuselages, installed engines, and tested systems. Women in particular played a critical role in the production lines, riveting panels, wiring control systems, and ensuring that each bomber met the exacting specifications demanded by the military. Every member of the team understood that failure was not an option. The aircraft was intended to change the course of the war, and every mistake could have cascading consequences. The collaboration between engineers and pilots, between designers and factory workers, exemplified a wartime unity of purpose that transcended individual talent. Each breakthrough, a functioning pressurized cabin, a reliable engine, or an accurate remote gun turret, represented months of labor, countless experiments, and the unwavering commitment of ordinary people performing extraordinary work. The story of the B-29's engineering is also one of iteration and adaptation. Early test flights revealed unforeseen weaknesses, structural flexing in the wings, turbulence effects on control surfaces, and even problems with electrical systems freezing or shorting at altitude. Engineers and pilots had to adapt quickly, redesigning components, reinforcing structures, and recalibrating instruments. Every test flight was an exercise in problem-solving under pressure, with the clock ticking as the Pacific War raged on. Delays were frequent and costly, yet each delay reflected the complexity and ambition of what the United States was attempting, to produce a bomber that was not only the most advanced of its time but capable of striking deep into enemy territory with unprecedented destructive power. In the end, the B-29 emerged from this crucible of engineering challenges as a marvel of human creativity and determination. It was a plane born not only from technical genius but from relentless human effort, pilots who risked their lives to test fragile prototypes, mechanics who solved problems with ingenuity, and engineers who refused to accept conventional limits. Every rivet and every engine bore the mark of thousands of individuals striving toward a single goal: an aircraft capable of ending a war by reaching the enemy where no other bomber could. The B-29 Superfortress, once derided as the worst bomber, was transformed through perseverance, innovation, and human determination into a weapon that would change the course of history. Trial by fire. The B-29 Superfortress, despite its engineering marvels, was immediately put to the ultimate test: combat over the Pacific. Early missions were a trial by fire in the most literal sense. Crews who had trained for months were thrust into the unforgiving reality of warfare, flying over vast ocean stretches toward heavily defended Japanese cities. From the moment they lifted off, the bomber revealed its vulnerabilities. The Wright R-3350 engines, once the pride and bane of the engineering teams, continued to overheat and occasionally catch fire mid-flight, forcing pilots to make split-second decisions to save both their crew and their precious cargo of bombs. Mechanical failures weren't limited to engines. Pressurization systems sometimes malfunctioned, causing oxygen shortages, while remote gun turrets occasionally froze or misfired, leaving crews exposed to enemy fighters. The combination of technical risk, long-range missions, and fierce enemy defenses created a deadly environment, where every flight felt like a gamble between survival and disaster. Skepticism among the crews ran high. Many pilots, navigators, and bombardiers viewed the B-29 with deep suspicion, dubbing it a flying death trap in private conversations. They had trained on simulators, practiced emergency procedures, and yet nothing could fully prepare them for the stress of commanding an untested aircraft under hostile fire. Morale wavered as news of engine fires, aborted missions, and mid-air losses filtered back to the airfields. Some crews questioned the engineers' claims of superiority, wondering if the B-29's promise of long-range strategic bombing would ever outweigh its perilous flaws. Every mission brought tension not only from enemy anti-aircraft fire and Japanese fighters, but from the constant fear that the aircraft itself might betray them. The psychological burden on crews was immense. The aircraft represented both their salvation and their potential doom. Meanwhile, engineers and maintenance teams on the ground responded with relentless determination. Every returned bomber was dissected, each failure meticulously analyzed. Mechanics and engineers worked around the clock, often in extreme heat and humidity of the Pacific Islands, to rebuild engines, recalibrate instruments, and repair structural damage. Test pilots were called in to diagnose problems under controlled conditions, while engineers revised designs mid-war, applying lessons from each sortie to improve reliability. The collaboration between flight crews and engineers became crucial. Feedback from pilots on mechanical behavior, fuel consumption, and performance under fire directly informed technical adjustments. This dynamic was a testament to wartime ingenuity, a feedback loop where real combat provided the data that engineering manuals could never replicate. Despite the high risks, the B-29 gradually proved its resilience. Lessons learned from early missions led to critical improvements. Engines were modified for better cooling, fuel systems were reinforced to prevent leaks, and structural weak points were strengthened. Flight procedures were adjusted, emphasizing staggered takeoffs, formation flying, and in-flight monitoring to detect early signs of engine stress. By incorporating these lessons, each subsequent mission saw fewer mechanical failures, reduced losses, and greater mission success. Engineers developed new maintenance protocols that allowed ground crews to perform rapid inspections and repairs under combat conditions, ensuring that more aircraft could remain operational despite the harsh realities of war. As reliability improved, crews' confidence began to grow. What was once a flying risk now became a platform of strategic power, capable of reaching targets that no other bomber could strike. Morale shifted as crews realized that the plane's early failures were not a death sentence but a necessary stage in refining a revolutionary weapon. Pilots began to respect the aircraft for its sheer capability. The B-29 could fly higher, faster, and farther than any previous bomber, allowing attacks deep into enemy territory with unprecedented payload capacity. The combination of technological innovation and human perseverance turned skepticism into cautious optimism, transforming the perception of the worst bomber into a symbol of American industrial and military ingenuity. This period of trial by fire also underscored the human cost of pushing the limits of technology. Every mission carried risk not just from enemy defenses, but from the aircraft's inherent complexity. Yet, the determination of engineers and courage of crews forged a machine that could deliver strategic results impossible for conventional bombers. Lessons learned during these early combat sorties became the foundation for the B-29's later successes in Japan, proving that even the most flawed machine could be transformed through relentless problem-solving, innovation, and human courage. By the time the Superfortress became the centerpiece of the strategic bombing campaign, it had endured a baptism of fire that tested every rivet, every engine, and every crew member, and emerged not merely functional but decisive. The B-29's early combat trials exemplify the intersection of human ingenuity, technological innovation, and bravery. Through trial, failure, and adaptation, what began as a worst bomber transformed into a weapon that would ultimately help bring a brutal and far-reaching conflict to an end, redefining both the plane's legacy and the concept of strategic bombing. The turning point. By late 1944, the B-29 Superfortress, once considered a technological nightmare, was ready to demonstrate its true potential under the command of General Curtis LeMay. LeMay, a visionary strategist, recognized that conventional high-altitude bombing had severe limitations over Japan. Frequent cloud cover reduced bombing accuracy, and jet streams caused bombs to drift off target. To maximize the B-29's effectiveness, he devised a radical shift in tactics: low-altitude, nighttime incendiary raids designed to destroy industrial targets and civilian infrastructure critical to Japan's war effort. This approach was risky. Flying lower increased exposure to anti-aircraft fire, and nighttime operations required precise navigation and coordination. Yet it leveraged the B-29's unique advantages: long range, large payload, and heavy defensive armament. Crews trained rigorously for these missions, learning to navigate vast stretches of ocean in darkness, approach cities silently, and deliver devastating payloads with pinpoint accuracy. The first missions under LeMay's revised strategy immediately revealed the Superfortress's destructive power. Cities that had previously seemed impervious to Allied bombing were now engulfed in firestorms. Wooden residential neighborhoods, densely packed and poorly defended, ignited almost instantaneously when hit with incendiary bombs. Entire industrial districts were rendered inoperable within hours, crippling Japan's ability to produce aircraft, ships, and munitions. The psychological impact on Japanese civilians and military planners was profound. The sudden appearance of these massive bombers in the night sky, coupled with the devastating effect of their payloads, shattered morale and created a pervasive sense of vulnerability. Reports from the ground described infernos that consumed entire neighborhoods, a level of destruction previously unimaginable. What had been a bomber plagued with engineering flaws had now become a symbol of strategic might and technological supremacy, turning skepticism into awe. LeMay's tactics also demonstrated the adaptability and resilience of the B-29 and its crews. Aircraft that had once been prone to engine fires were now operating reliably even under the stress of low-altitude, high-speed night raids. Maintenance crews had mastered the art of rapid repairs, ensuring that the fleet remained operational despite intense operational tempo. Pilots and bombardiers who had doubted the Superfortress's capabilities were now relying on it as the backbone of their missions, navigating treacherous Japanese airspace with confidence. The B-29 had transitioned from a worst bomber to an indispensable instrument of war, illustrating how human ingenuity in tactics and engineering could transform a flawed machine into a decisive weapon. The cumulative effect of these raids was staggering. Entire urban centers, including the likes of Tokyo, Kobe, and Nagoya, were reduced to rubble, significantly hindering Japan's ability to sustain its war effort. Strategic targets such as factories, communication hubs, and transportation infrastructure were destroyed with unprecedented efficiency. The B-29's ability to strike deep into enemy territory without requiring forward bases fundamentally shifted the balance in the Pacific theater. Japanese military planners, who had previously dismissed the aircraft as another Allied bomber, were forced to confront the reality that this new weapon could operate with impunity over their homeland, striking targets previously considered out of reach. What makes this turning point particularly remarkable is the transformation in perception. The same bomber that had been derided for mechanical unreliability, engine fires, and complex maintenance had become the linchpin of an air campaign that directly contributed to the weakening of Japan's military-industrial complex. Strategic bombing, once limited by range and accuracy, now had a potent tool capable of reshaping the theater of war. The combination of LeMay's tactical ingenuity, the Superfortress's engineering evolution, and the crew's perseverance exemplified how adversity can foster innovation, and how the convergence of technology and strategy can turn an apparent liability into a decisive advantage. By the end of these early incendiary campaigns, the B-29 had firmly shed its reputation as a worst bomber. Its payload capacity, range, and resilience made it the cornerstone of America's aerial offensive. Cities burned, factories ceased production, and Japanese morale plummeted. The bomber's transformation illustrated a broader lesson of the war. Even machines initially deemed failures could achieve historic significance when paired with human creativity, strategic vision, and relentless adaptation. In this pivotal chapter, the B-29 Superfortress proved that the label worst was temporary, and that under the right conditions, even the most criticized tool could become indispensable in ending a global conflict. Endgame. The war ends. By mid-1945, the B-29 Superfortress, once derided as America's worst bomber, had become the most consequential aircraft of the Pacific War. Its long-range capability, unprecedented payload, and innovative design made it the only plane capable of delivering the war-ending atomic bombs on Japan. The culmination of years of technical struggle, engineering breakthroughs, and tactical evolution came to a head in August 1945, when two B-29s, Enola Gay and Boxcar, carried out missions that would reshape global history. The missions required meticulous planning, including precise navigation over thousands of miles of ocean, timing to avoid enemy defenses, and coordination to release payloads that had never before been deployed in combat. Without the B-29's pressurized cabins, advanced engines, and enormous payload capacity, such a mission would have been impossible. The dropping of the atomic bombs on Hiroshima on August 6 and Nagasaki on August 9 marked a decisive turning point in the war. Cities that had once been the target of incendiary raids were now subjected to a weapon of unimaginable destructive power. The B-29, designed initially for high-altitude precision bombing and plagued by engineering failures, had become the instrument through which the United States forced Japan to surrender. Its capacity to carry over 20,000 pounds of bombs and fly at altitudes beyond the reach of conventional Japanese defenses made it uniquely suited for the mission. Pilots and crews, who had trained for years under grueling conditions, now executed the most historic bombing operations in human history, cementing the aircraft's legacy not as a failed project but as a war-ending machine. This transformation, from unreliable maintenance-heavy bomber to decisive weapon of mass impact, illustrates how innovation, persistence, and adaptability can turn failure into historic success. The same aircraft that struggled with engine fires, structural weaknesses, and skepticism from military leaders had become the centerpiece of a strategy that saved countless American lives by shortening the war. The psychological effect on Japan was immediate. Facing a weapon and an aircraft capable of delivering such devastation, the Japanese leadership realized that continued resistance was futile. The surrender that followed was not only a political and military event, but also a testament to the long, difficult evolution of the B-29. In the broader context, the B-29's journey demonstrates the interplay of human ingenuity, technical innovation, and operational adaptation. Engineers had overcome nearly every obstacle, from remote-controlled defensive turrets to pressurization systems and complex engine configurations. Strategists like General Curtis LeMay refined tactics to maximize effectiveness, and aircrews endured relentless training and combat missions. Each challenge, each failure, contributed to the aircraft's ultimate capability. By the end of the war, the B-29 had earned its place as the plane that could reach the heart of Japan, deliver an unprecedented payload, and compel surrender, turning a worst bomber into the instrument that brought the global conflict to a close. The story of the B-29 underscores the broader lesson of wartime innovation. Success often arises from the combination of visionary engineering, persistent problem-solving, and tactical audacity. What was once considered an impractical and unreliable aircraft became a decisive force that reshaped history. In the end, the Superfortress was not merely a bomber. It was a symbol of how determination, innovation, and adaptation can convert initial failure into a world-changing victory. The plane's transformation from ridicule to reverence highlights that sometimes the most doubted tools, when refined and applied strategically, can become the instruments that define the outcome of history. Unsung heroes. Behind the legendary status of the B-29 Superfortress were the countless men and women whose tireless efforts made its success possible. Pilots who flew long, dangerous missions over enemy territory faced constant mechanical failures, extreme weather, and the ever-present threat of anti-aircraft fire. Crews who maintained these complex machines worked under relentless pressure, often repairing engines that overheated or fixing systems that failed mid-flight, knowing that any mistake could cost lives. Engineers back in factories and testing facilities had to overcome unprecedented technical challenges: pressurized cabins, remote-controlled defensive turrets, and advanced engines that pushed the limits of 1940s aviation technology. Every innovation came with trial and error, and every setback demanded persistence, ingenuity, and courage. These ordinary people, farmers, mechanics, factory workers, and pilots, were the true architects of the B-29's transformation from an unreliable worst bomber into a decisive instrument of war. Unlike the machines they served, they brought adaptability, creativity, and human judgment to every problem, turning design flaws into opportunities for improvement and mechanical failures into lessons that saved lives. Without their dedication, The bomber would never have reached the level of reliability required for the critical missions over Japan, let alone for carrying the atomic bombs that ended the war. Their stories are often overshadowed by headlines of destructive power and military strategy, yet it was their human effort that amplified the technological capabilities of the aircraft into historical significance. The contrast between these unsung heroes and the destructive power of the B-29 is striking. While the plane could deliver devastation from the skies, it was the ingenuity, endurance, and courage of ordinary people that transformed potential failure into a weapon that could decisively end the war. Each mission, each repair, each innovation represented the intersection of human persistence and technological ambition, proving that machines alone cannot achieve history-changing results. People must make them work. In reflecting on the B-29, it becomes clear that its success was not just a story of engineering triumph, but a tribute to those whose skill, determination, and resilience turned the worst bomber into a legend. Legacy and reflection. The story of the B-29 Superfortress did not end with the conclusion of World War II. In many ways, it marked the beginning of a new era in aviation, strategic thinking, and human ingenuity. After the war, the B-29 became the blueprint for modern long-range bombers, influencing the design of the Cold War strategic fleets, including the B-36 Peacemaker, B-52 Stratofortress, and subsequent generations of high-altitude, long-range aircraft. Its innovations, pressurized cabins, remote-controlled defensive armaments, advanced engines capable of sustained high-altitude performance, were revolutionary at the time, and their legacy can still be seen in today's sophisticated military and civilian aircraft. The lessons learned from operating, maintaining, and continuously improving the B-29 informed aviation engineering, highlighting the critical interplay between human expertise and technological ambition. Engineers and pilots who worked on the B-29 established protocols for aircraft maintenance, crew training, and operational strategy that would serve as the foundation for decades of aviation development. Beyond technical influence, the B-29 story carries a deeper lesson about human innovation overcoming adversity. The bomber itself, initially dismissed as unreliable and dangerous, was transformed through perseverance, creativity, and relentless problem-solving. It illustrates that even the most flawed designs can be made into instruments of historic significance if approached with determination and intellect. The early failures, overheating engines, structural flaws, misfires, and high losses, were not signs of hopelessness. They were opportunities for learning and improvement. Each setback prompted new solutions, new strategies, and ultimately a reimagining of what the aircraft could achieve. This reflection resonates far beyond military aviation, serving as a timeless lesson for any field where innovation is key. Obstacles are not endpoints but stepping stones, and failure is often the catalyst for transformative success. The B-29 also reflects the extraordinary human dimension behind technological achievement. While the aircraft itself became iconic, it was the collective effort of thousands, engineers drafting new solutions, mechanics performing daring repairs under dangerous conditions, pilots navigating enemy skies, and crews enduring the unimaginable pressures of extended missions that brought it to life. The story of the B-29 reminds us that technology alone does not define history. It is the people who operate, maintain, and refine it who turn potential into reality. Ordinary men and women, many of them young and inexperienced at the war's outset, rose to the occasion, displaying resilience, creativity, and courage that rivaled the most advanced machinery. In doing so, they bridged the gap between invention and application, failure and victory, potential and historical impact. In examining the legacy of the B-29, one also sees the profound impact of perspective and vision. What was once labeled the worst bomber became an unparalleled tool of strategic warfare, ultimately shaping the outcome of a global conflict. Its story underscores a central truth about progress. The value of an idea or a machine is not fixed at birth but evolves through adaptation, effort, and human ingenuity. The B-29's transformation from an object of doubt to a symbol of power and precision captures the essence of resilience and underscores the capacity for human beings to turn even the most challenging circumstances into lasting achievement. As the world reflects on the lessons of the B-29, it becomes clear that its historical significance is twofold. First, it demonstrates the transformative power of innovation under pressure, showing how technical mastery, coupled with perseverance, can overcome initial shortcomings. Second, it serves as a tribute to the unsung heroes who, through creativity, skill, and endurance, converted a problematic aircraft into a decisive instrument of victory. The bomber stands as a testament not only to engineering brilliance but to the enduring human spirit, the willingness to confront difficulty, to learn from mistakes, and to persist until success is achieved. In the final analysis, the B-29 Superfortress exemplifies how adversity, when met with imagination and dedication, can produce outcomes far beyond initial expectations. It serves as a reminder that failure is not the opposite of success but often its precursor, that even the worst can become extraordinary when combined with vision, effort, and courage. The legacy of the B-29 is etched not just in the annals of military history but in the broader story of human innovation, the persistent drive to transform possibility into reality, to turn setbacks into breakthroughs, and to make the improbable achievable. As we close this chapter of history, it is fitting to reflect on the wisdom of those who understand the alchemy of resilience and ingenuity. The B-29 teaches us that determination and creativity can elevate even the most flawed instrument into a force capable of changing the course of history. In the words of famed aviation pioneer Orville Wright, which resonate profoundly with the B-29 story, the airplane stays up because it doesn't have the time to fall. Likewise, the B-29 soared above doubt, defied its initial failures, and ultimately rose to the occasion, transforming from the worst bomber into the plane that ended the war.